Yeah. Oh, actually, first of all, yeah, a couple of words about myself. Like, hi, I'm Georgios. Currently I'm on DeepMind. I'm also a professor on leave currently. And I've been collaborating with Ethereum back from around like 2017. So had discussions with, Vitalik and many other people, Vlad Zamfir, Virgil Griffith, and this is has been an ongoing discussion, has been very instructive from my perspective, because it helped me somehow, coming from a background roughly in theoretical computer science, it helped me somehow question hidden assumptions that somehow was very myopic to, treat it, being, emerging from a theoretical area where you really like to prove things, and you tend to develop somehow some myopia on hidden assumptions of your model, right? And now, talking to Vitalik, it's like, oh yeah, this is great proof. This is not going to work. Here's why, like immediately, And then somehow I tried to develop a methodology, actually a mnemonic rule, in terms of like where do these assumptions are hidden, okay? And this, I want to briefly share this with you. And hopefully this could be valuable to your research too. Is there any way to erase? Maybe we just take this off. Okay, perfect. Thank you. Yeah. All right. So I will go over the, okay. So the word to remember is presto. Okay. The T is not capitalized. Okay. And then I will go through each of these letters, and I will say like, here's the related concept to keep in mind. Okay. So yeah, and this is not in order. Okay. So we start with O. O stands for optimality. All right. So this asks, okay, how well does the system solve the problem that you're looking for? For example, let's say here where you have your global metric. You think of your loss function, or let's say I want to like maximize social welfare of my system, my users. Okay, how close does my solution come to, satisfying this data in the system? Okay. The second E is for efficiency. All right. Efficiency says that like, okay, in pursuit of my first goal of optimality, my system is going to use a bunch of resources. Resources come in different flavor. Resources can be time, it can be space, it can be the use of randomness. It can be things like network bandwidth and so on and so forth. All right. And actually, this is where theoretical and actually computer science like lives. So we work on the intersection of these two areas. If we only care about optimality, we'll be mathematicians. But we don't care just for like finding solutions of SAT. We want to find them, let's say, as fast as possible. Okay. But then we just say like, okay, some algorithms, we cannot make them run in deterministic time, poly time, but maybe randomness can be very, very helpful. And understanding these trade-offs, or let's say decentralized computation. Like, what can I do if I don't have to have all of my data in one space? Okay. So this is what the theoretical computer science does. Okay. But actually not all computer scientists, let's say people like myself and David, we go further down into this word. And then now we think about ST, which we call like stability or stationarity. All right. So now we say like, okay, great. You have a system. Your system is, let's say, approximately optimal, approximately efficient. Now, is it the case that the system in itself is in equilibrium? Okay. That somehow the agents who implement the system, they're not forced somehow to participate. Okay. But if given the opportunity to participate, then they will actually follow the system. Right. And now this can actually come with many different flavors. Let's say, from the classical perspective of mechanism design, we think of stability from the perspective, let's say, of the users. The users is like, I'm coming and I participate in an auction. Am I going to bid truthfully? If the mechanism is, let's say, strategy proof, that's the whole idea, right? That it's in your best interest to bid your true value. But stability or stationarity could also be applicable to other entities, like the designer themselves, right? So, for example, David talked about credible mechanisms. Credible mechanisms, suppose I viewed my mechanism from the perspective of the designer. Would the designer actually stay in this point in the mechanism space, or they would deviate themselves, right? Okay, so this is already like pretty packed, but we're actually not done, okay? Suppose you've done this, which is already, pretty impressive. So you create like, credible, super stable mechanism that's efficient and optimal. Are you done? Well, no. Vitaly, you say, well, this is where we start, Like you say, what about robustness? Okay. Now, this is actually a tricky concept. It would say like, to talk about robustness, you actually have to topologize somehow your protocol. So your protocol, think of your protocol, your solution, as a point in some space. Okay. So let's say, what would be the easiest way to think about this? Let me think about the following. Okay, so when you take, let's say, when you think about standard mechanism design, like you think that, let's say, all of the agents are perfectly rational. Okay, but now you could say like, okay, what if I allow an 1% of Byzantine agents? Okay, now this is not in my original, so I've expanded my space to sort of like invalidate some of my assumptions of the protocol. Okay, so I'm looking in the larger space. And now I'm going to try to understand how do my guarantees that I have understood before degrade as I move further and further away, as my assumptions of my model get invalidated. Okay, so for example, could it be the case that, if we have like 3% Byzantine agents or 10% Byzantine agents, like that at some point there's a violent phase transition, right? And your system performance goes from 100% to 0. Like Vitaly, say, okay, we have to think very, very carefully about this, right? And then there's the very last point of this that I call persistence. Okay. So robustness is an issue about local deviations. Okay. So you say like, okay, look, I've written a very nice mathematical model, but there's always misspecification on my model between model and reality. These specifications will be typically small because I've done quite a bit of work in terms of like believing my model, make the model good. Okay, so as long as my guarantees are, let's say, they degrade gracefully, then my system is robust. But then, like, and this really comes from Vitalik and Vlad, and the early days of Ethereum, we think, what about a nefarious entity that comes in and let's say they're willing to burn like $100 million to destroy Ethereum? Okay, how would they do it? So there, you have to be forced to think about radically somehow moving. Okay, if you're again in your parameter space here, so this is your point in your parameter space. Now you've been moved very far away. Okay, right? And now you want to think about, is my actual, let's say, system here, my design system itself an attractor? So somehow, like, if it was like violently to move away from its point of specification, okay, then it would actually self-organize to what I actually chose, right? And this somewhat reminds me of what Barnaby said about this point of last defense, So you think about, like, now you really have to think very, very carefully about this almost like black swan kind of events, because if you want to create something that has like true, persistence in the real world, like eventually something very, very awful will happen. Now, clearly, I'm not saying that, okay, you should create a system that like checks all of these boxes, right? But the ways to think about this more like a Pareto frontier. So make your choices. Let's say, for example, I really care about, this, and this, 10%. Maybe this is like maybe not relevant to me. Okay, but somehow at least being like going through this checklist, and this also like applies for like AI safety issues. Like, I think it's also be useful for you. Going through this checklist can really so much help you discover these blindfolds. Right, and if you want to look at more details about these ideas, these appear on a joint paper with Stefanos. So the way to Google this, I would guess it would be Leonardos et al. And Presto. Okay, and so this is John Stefanos and with Daniel Ratsberger at SGD. Yeah, so that's it. Yeah, and I'm happy to take questions and kickstart the discussion. Sorry, Vincent. Sorry, this is the end of the monologue. Okay, that's it. Yes.
I was wondering if you could talk about useful theoretical framework to encompass all these parameters. Like it seems like I'm not like an expert in it, but like it seems like some kind of complex system theory, like actually metrics to like be able to characterize these properties like in a system. Like I was wondering if you went as far as actually like coming up with some kind of key metrics or like useful frameworks to evaluate your system and design it. So like it's just hard to come to all of it, but I think it's even harder to actually come up with useful metrics that can evaluate the model while to design it.
Well, I mean, I would answer it like in two ways. So like in one sense, yes. So I have done some work exactly at instantiating these things, like in a specific like formal ways. But I would actually encourage you not necessarily, but in some sense, I don't feel that there's a unique way of translating these ideas to useful mathematical frameworks. There have been some ways that have been useful for my research. Okay. But I don't want to stand here and like advocate, like, no, this is the way to doing this. And clearly here, I mean, like there's a lot of analogies, of course, with like what, David was saying like this morning. And this is not by any means somehow, like, I'm not going to fight here, like, oh, you just use my terminology, right? All I'm saying is that like, this is something that has been useful for me, like in my work, specifically in blockchain systems, to think about things that I take for granted. Okay. And I would encourage you to try it out or develop your own methodologies and again, like explore the literature for related work. Okay, that's it. Yeah.
I'm sorry, was that a question to me? I can't really hear. I could hear Georgios as well. Yes, okay, great. So yeah, I can hear some people well and others not as well. But first of all, thank you so much for having me here very much at the last minute. I'm sorry to jump in remotely. I'm happy to see some familiar faces. I see David there. I saw Vangelis earlier and Georgios, of course. So hi, everybody. My role in this panel, first of all, I'm not a blockchain expert. I'm interested in it. But my expertise that's relevant here probably is coming a little bit more on the cooperative AI side. And in particular there, I have more of a game theory view on that. I run the Foundations of Cooperative AI lab at Carnegie Mellon University. I also have a part-time appointment in Oxford, but this happens to be the time that I'm not there. So generally, what's of interest to me is just kind of abstractly thinking about languages in which you can express very general commitments, right? So we're very interested. I've done a lot of work over the years on commitment and game theory, in mechanism design, and now increasingly also in program equilibrium type of setups where we commit to a program in some sense. So their commitment seems like it can be very helpful to attain cooperation and to establish trust in all these things. At the same time, we're also learning that, commitment isn't always a good thing. And there are certain kinds of commitment that in broader society, we actually try to avoid, right? Commitments could also lead to things like extortion or collusion or vote buying. And I imagine many of those are interesting to you as well. So that's kind of where I'm sitting, that I kind of want to think about, well, how do you structure things so that you get the good kinds of commitments and not the bad ones, the ones that result in beneficial cooperation rather than collusion and extortion and these types of things. I know Casper and Lewis, I think, are going to be there tomorrow as well, and you're in good hands with them. And so, I don't need to talk too much, but if I can be helpful with anything, that's great. And otherwise, again, you're in great hands with Casper and Lewis tomorrow.
Oh, okay. So can you hear us right now? Okay, great. Barnaby, can you? Yes, yes. So, okay. Okay, nice. So yeah, we're going to have like sometime, maybe 40 minutes with Vincent and Georgios to answer some questions about commitments. Some of these questions were asked to you with this quadratic voting mechanism. We got 4 replies. So we have some data to know which questions are the most interesting to the audience to ask. And so, yeah, first, so one question that was seemingly very interesting to the audience is the idea that commitment devices, what are their roles, limitations, and trade-offs? And specifically, the question was, both crypto and cooperative AI have focused significantly on commitment devices, a decentralized way of implementing coordination. So how does this study in crypto, blockchain, and cooperative AI relate to what we know from, let's say, traditional literature on the way to implement coordination with, for instance, mediators or mechanism design? Maybe Vincent, can you take this question first?
Yeah, great. I do think there's a lot of overlap, again, especially at this kind of abstract level of thinking about the languages in which we make commitments and the ways in which we make commitments. And I think both cooperative AI and also blockchain have somewhat of a decentralized view that there isn't necessarily a well-established institution already. In blockchain, maybe you have a protocol, but besides that, things can emerge naturally. And in some ways, that's a nice environment, but in other ways, there may be also things to worry about, right? That somebody gets some kind of strange first mover advantage that leads to extortionary dynamics or other bad dynamics. And so how do you prevent that? I think I don't have the answer to that at this point, but I think that's a good thing to think about. And one thing that seems to play a large role also is who has access to which information, right? That if we can have a private side channel within which we can also make commitments, that is something that can enable collusion better than, for example, if everything is necessarily public. But how do you keep things public if they can be encrypted and so on? So that's, I think, one aspect. Also from the mechanism design angle, there's a question of whether all the information is already included, right? Normally in mechanism design, we think about, there are things like the revelation principle, which tell us that, well, in some sense, we can simplify the mechanism, but in the end, from the user or from whoever we value, we still need this input of what is it that they actually value, how much do they value it, and without that, we can't necessarily play the game. And again, I think in this context, there are interesting questions about to what extent is that private information already out there, and can you commit to it? To what extent do you eventually need to query a human being where you can't really monitor or make any kind of guarantees about what they might say? And how does that play into these stories about commitment and cooperation? So I think that I just listed off a whole bunch of different things, but I think those are some of the things that are relevant to all of us.
Yeah, very nice answer.
Right. Yeah, I'll happily take a stab at this. I would say, yeah, definitely there's a lot of interest from both communities, let's say, on this issue of commitment. But probably from a somewhat different perspective, I would say like the way I think of commitment in blockchain is a very somehow like practice-oriented like first approach. Okay, so how are we going to resolve the issues of a resolution? Okay, here's like a hard limit on gas. Like if your program needs more steps, like tough luck, right? So on the other hand, somehow Vincent, and his group, there's done, of course, like very elegant theoretical work of understanding very powerful commitment devices and what you can and do with them. And I think it would be very interesting somehow to try to maybe follow a kind of like gradient. If I would go to combine maybe like David's perspective here, and I would say, okay, let's think of suppose think of like, how Ethereum does, commitment resolution like today. And then you say like, okay, what's the most promising direction? What's the minimum minimum capabilities that we can add to the system? That's what they are like, so that like they maximize somehow like the promise of the systems, right? So I think here's like where, and then it's not about like implementing everything, but like somehow again, like going for a minimal change, like literally somehow like a gradual step. So it could be very, very useful if somehow like some of this rather general theory could be somehow like revisited from that perspective, right?
And going at it gradually, is this also perhaps a way to hedge against the risks that Vincent was talking about, that when you expand the space for people to make commitment, you might also expand the space of bad commitments that they can do with it, and perhaps going at it piecewise and just adding features one by one is one way to kind of check that it works well along the way? Or is that insufficient, as AI safety, for instance, thinks about it, which is that, either you have an AGI or you don't have an AGI, and there's not really like a way to be in the middle?
Well, okay, if I would take this, okay, maybe part of my answer is already on the board. Like, like it's always a good idea to like move in small steps. Why? Because, maybe in a real world, like most of the properties of most systems are like relatively stable. So hopefully, if you do like a small change in the system, like you won't create like a catastrophic error, okay? Like that being said, we do know that there are systems which undergo critical phase transitions. And I think like that's a lot where like the real like theory comes into play, and say like, okay, like do we have evidence to believe that like, we're close to such a regime? And then, we can try to study this both theoretically and somehow experimentally, right? And then as long as we don't see any sort of like evidence for such phenomena, then I think we can be more confident that a small step won't be the catastrophic one.
I agree. I think, and this is a context where we definitely can do experiments as well, right? Maybe some things fail, but sometimes it's really good to see what actually happens in practice. And some of these things are so complex to think about. Casper has some nice stories about earlier program equilibrium type of competitions and kind of Axelrod tournament style, where at that point, a lot of people were thinking about logical analysis of the other programs and establishing cooperation that way. But it seemed that the competition just evolved into this weird situation that a lot of people put some key words into their code that made it look like they were thinking about cooperation and so on. But in the end, they were all just affecting on each other and trying to, in very superficial ways, trick the other programs into cooperating. Could you have predicted that? Well, maybe, but in any case, I think it's good to do those experiments. And I think this is a context where we can have fairly, not all too high of stakes experiments. They need to be high enough that people are really motivated to actually try things and come up with, for example, if we're worried about extortion being possible in this kind of framework, we actually want to incentivize people to try to do that to the extent that we have an experiment and we want to learn what is possible and what isn't. So we need some stakes, but at the same time, the stakes can still be low enough that we can think of it as an experiment.
Speaking of stakes, I think like Ethereum, has offered like a great example of such a transition like in the real world, right? So the transition from proof of work to proof of stake, like this goes back to discussions with like Vitalik and Virgil, like up on around like 2017, where like that's when the first somehow like theoretical work happened, and we know that in theory this would work, but then of course you start like testing it. Initially you have like computer experiments. Then you move to testnets, multiple testnets developed by independent groups. This gives you confidence on that it's not a fluke. And then eventually, you actually do like the change in the mainnet, right? So like, there's not one step, there's like multiple steps, right? Yeah. But, but this is actually like a great success story for theory. Like this whole started with like, pen and paper arguments where we say like, look, you can do everything without game theory and not somehow like burning millions of dinosaurs like per day, So so hopefully maybe we can replicate some of this idea, for other elements of the protocol.
Nice. Yeah, I really want to come back on the program equilibrium, because this was something that was highly rated in our informal survey. But before moving there, there was a question about, we often think of blockchains as their value proposition is really about being this available commitment device that is just sitting there and that people can deploy things to. But we have only recently been thinking about this whole strand of literature that has been existing for quite a while on the idea of commitments in games and exactly this principal agent problems, DAOs of extortion, the credibility of mechanisms. As a, let's say, practitioner of this field for quite a while, is there something that we should have on top of our mind when we're thinking about this problem? Like, we're coming in with fresh eyes, but is there maybe like a critical learning from the field that we should be very mindful of and that seems to apply in this situation? Maybe this was a question for Vincent.
Sorry, I thought you were talking about blockchain practitioners, which I'm not.
Commitment devices practitioner.
Yeah, this is good. So I think in game theory and mechanism design, right, most of the literature on commitment is sort of implicitly in mechanism design, that there is some entity out there that is in a position that they can commit to the rules of the game. And they're often creating the rules of the game for other players, right? That in the end, often we think about the mechanism designer or whoever's running the mechanism as not really even a player in the game. They're just setting up the rules. And that's the way that we get commitment. And that's a kind of commitment that I think also in these contexts can be helpful. But at the same time here, maybe we are thinking a little bit more about players that are at the same level. When we're talking about program equilibrium, then we're really talking at some level about this mutual commitment, right? That's I commit to do something if you do the same thing and vice versa. And that is in some ways very powerful to get things started, right? And to build up from nothing. But there are a lot of details there about how those commitments come to be. And again, like, if you have somebody who is a first mover and who can commit to something before anybody else, that radically changes things. A lot of these program equilibrium concepts actually allow for many different equilibria, right? And so that's another issue, that there may be a difficult equilibrium selection problem. Again, a first mover might try to take most of the benefits from the cooperation, but at the same time that might also fail, and somebody else might be trying to select a different equilibrium. So at some level, maybe you still need some kind of norms and expectations, because again, there are so many different equilibria that you could have in principle, that in the end, there probably needs to be some kind of community enforcement of whatever standards we're trying to uphold, to prevent things from going all too far in the wrong direction. And so that's very interesting, like to what extent would that emerge naturally, and would that emerge in a good way? Or do we need to think about that more proactively beforehand and think about what should be the norms? What is the kind of behavior that we should be punishing, and what mechanisms do we have to punish certain kinds of behavior or block it? Or those, I think, are difficult questions that, again, probably, experiments would be very interesting to me to see what actually would happen. But I think we also still, to some extent, lack the abstract framework. Right, so that even though there is now, there has been for quite a few years this literature, a lot of it gets very complex very quickly, and we usually look at fairly abstract models where everybody gets to commit at the same time, everybody gets to see everything, and that's easier for us to do the analysis, but may not really track the real world, especially as there is, private information that's being held somewhere that we can't see. People move at different times. We have dynamics. There's updates about the world coming in, and we have to be a little bit flexible. People are maybe not going to use every aspect of the language that you provide them with. And so presumably, again, there will be some evolution of the kinds of things that people express and that they know how to analyze, and that then their programs will be looking for to see. So I feel like there could be many different kinds of equilibria. And so the key questions are, how do you converge the good ones? To some extent, we can try to maybe design the good ones, or at least encourage people to use the good ones, make those sort of very focal or salient that like, okay, well, this is really the natural thing to do. My worry is that things can go wrong in a number of ways if we're not mindful and if we don't have the ability to roll some things back some of the time.
Want to? Is there something that the blockchain community should know about AGT that we're not paying attention to?
Yeah, that's a good question. I think there's at least for like algorithmic game theory, I think that there's been like a good and I guess increasing communication between these two fields. So I don't think there's any sort of like real, absolutely a hidden secret. Hopefully not, like definitely not, but I think what we should be doing more is I think like remove more silos, right? So, and I think like this is something that's like that takes a lot of effort and somehow even, relationship between people in creating societies, right? And then we've been doing some of this work, like I think, for example, like EC has become like much more like blockchain friendly. And like, now of course there's a lot of professors in the area which are like with their students like doing work. And, and I think maybe the thing to sort of like to see next emerging is I would say like a tighter knit between the academic community studying commitments and, like, let's say maybe the more traditional ACT community that already speaks blockchains, right? So for example, like if I were to talk about this, here's a good idea, maybe like, I don't know if, AMAS is the home base, let's say, of commitment, theoretical commitment on research. But then like collocating AMAS and EC and having somehow like a tutorial by, Vincent and David on these kind of issues would be really helpful to spark somehow to accelerate research. Like, yeah, and again, somehow like the reason why I think we're doing, again, this work on why EC became much more blockchain friendly is because Ethereum actually with Vitalik, there was this like big tutorial back in 2018 or something in Ithaca. And then everybody said, oh, look, we can actually solve these problems. We're going to have like impact. These are like real world, and people got excited. And I think here clearly there's an exciting interface. And if we really start talking with each other, I think we're going to have like important impact. Mm-hmm. So, yeah. So, and I think, thank you guys for actually making this happen. Like I've never had this conversation before, and I think this is like a useful step in this direction for sure. Thanks.
Yeah, I agree with Georgios, and especially this idea also of having these kind of workshops, but also more broadly, we could have workshops, for example, also at EC to allow, right? Because usually these things are somewhat gradual that I think it's completely true that EC has become friendlier to this kind of work, but it's very gradual and it's little steps. And it's like, okay, here we can clearly see a mechanism design problem, right? So we jump on that, or here's a very clear game theory problem, where some of the other things are maybe still a little bit more speculative, and so it would benefit from having some kind of environment like this workshop, but also maybe workshops with with submissions at EC or something to allow people to experiment a little bit and think a little bit more about what could be a contribution, what could be a paper, maybe some papers that maybe aren't technically strong enough to be at EC yet, but have an interesting idea. I think we probably need some more of those venues.
Yeah, that would be definitely very nice. What would you say, the best approach? Like when you think about cooperative AI and the questions that the new types of AI are kind of raising, and when you think about blockchain, are they new objects for this theory of commitments? Like do they just extend the space beyond what the theory has been thinking about? Or are they objects that you can somehow represent them in this already existing theory? And maybe this informs the way to talk about it to people who are practitioners.
Yeah, I think, you'll find some people who say, well, basically everything you can model in game theory, right? And there's some truth to that. Game theory gives you this extremely general language for representing these kind of settings and thinking about them. But in part because it's so general, there's many things you could model within it, and many things have been modeled within it. I think this interaction, and thinking about blockchain specifically in this context, will get people to think about specific models, specific games to be played that we haven't really analyzed as such yet. So I do think that, yes, like at some abstract level, there's nothing new under the sun and we can model everything as a game. These specific setups we haven't really studied yet. And I think there's a lot of value in thinking about that. Some of that can, I think, probably be pretty abstract. Some of it, in some cases, maybe it doesn't really, the abstract analysis, it doesn't really matter whether it's on blockchain or not. You can, represent it fairly generically as a kind of commitment game, or maybe some kind of program game where you can commit to a certain program. That may then have applications on the blockchain. In other cases, I think there is, you probably do need to know a little bit more about the underlying architecture, and you can think about designing the underlying architecture in order to enable certain things that you otherwise couldn't do. So that's, I think, kind of the space to think about. Like, generally it's good to keep, in my view, keep things as abstract and general as possible without, losing the important aspects, but then also be able to go back and actually build these things and think about, well, what are the fundamental primitives that we need in order to enable these kinds of mechanisms, these kinds of commitment devices, and so on.
Right, and maybe to iterate a bit of this, and maybe to counter propose here. Here's I think that something would be very, very useful from the perspective of practitioners in the blockchain space, is to do something even in a more formalized way of your presentation today, where in some sense, like, I think you give like a very nice, high level, but also like a good level of detail of the current somehow like reality of the Ethereum ecosystem. And in some sense, like now, I would like to create something. I would like to see such a description that could almost act as as an API to say, like, look, now create somehow a program equilibrium specification that can actually talk to this abstraction, right? And this, of course, abstraction will not be, of course, Ethereum specific. It should be clearly more general, right? Mm-hmm. But I would say, like, look, we're gonna create something that's like at least feels more tailored, right, to the specific constraints, and this could allow us to make progress, right? Because it's exactly going to be these constraints that say, like, okay, look, we're not going to talk about everything under the sky, but we're going to talk about, like, let's say, program equilibria for blockchain. Mm-hmm. Mm-hmm.
Yeah, I really like that perspective. I think thinking about the APIs, or like, what are kind of the fundamental abstractions and interfaces that we need to be able to modularize and sort of say, well, I don't really care exactly about the underlying implementation as long as it gives me this, right? That's, I think, the level at which we want the interface between some of these cooperative AI ideas and actual implementations on the blockchain. And that's where we should have that conversation.
Mm-hmm. Mm-hmm. Yeah, because I do have a question as an expert in cooperative AI. Like, where is the dialogue on cooperative AI happening nowadays? I know this is kind of like diffuse discussion, right? Yeah, but like as an expert in the area, yeah, where would you go? Where would your best ideas like appear and so on? Help us.
So thank you for letting me advertise. So we have a cooperative AI summer school coming up in Oxford. Sorry, I think it's in London actually. And so that's in July, if I'm right. So that's coming up. So we're thinking about building up these events. You can talk more with Lewis as well. I think there's a plan for a NeurIPS workshop. So I think for now, it's a little bit of these special events. I think some of the work, right? We have a couple of ICHKAI papers on our work now that I think fits very much under the cooperative AI agenda. So there are the kind of familiar candidates of the AAAI, ICHKAI, AMOS's, also ECs of the world that are, I think, are a good home for at least the more game theoretic approaches to this. There are other approaches to cooperative AI as well, maybe a little bit more reinforcement learning oriented ones, for example, that naturally would have homes at NeurIPS, ICML. So I think so there's that aspect of it, like, some of the technical contributions will just be some part somewhere in some session of some bigger conference. But the kind of more dedicated events, I think, is also really valuable to think, where can we really have the discussion about what cooperative AI even is, which we're all still trying to figure out at some level as well. And so that's, the summer school will hopefully set some expectations for that. And then at some point, maybe we have more dedicated workshops as well. Maybe we can host something at CMU at some point. So I think we need some of those a little bit more dedicated events. Probably we won't have a whole separate conference like at the level of AMOS or even a smaller version of that just yet. I think it is valuable to have those papers appear in the more general venues. And that way you also get feedback, right? Because sometimes maybe we think we have an original idea, but somebody else as well, actually that's technically very close to this other thing, right? And so, it's important not to be too insular. But at the same time, we're definitely thinking about creating more of these venues and places to discuss more specifically, like what do we want this broader agenda to be? What kind of topics do we see as fitting in there? What's of interest to us? I think probably like with any academic area, that will kind of emerge over time, and it'll be a little bit of a like we know it when we see it kind of thing. But yeah, still very much in flux.
So we're being told that the room is actually closing, and I think we need to.
Yeah, 7 is a bad thing.
It's the same slab.
The 6:30 says that if you want to.
It's about coordination. Right?
Should we take another like 5 minutes and then just back up again?
Yeah. Okay. Then I'll finish then on one question was really about the future direction and the ways to take this further. I'll just read it because I think it was very nicely written. How can the field of AI leverage the benefits of cryptoeconomic commitments to address coordination and alignment challenges? And what might be the biggest potential obstacles in implementing something of this type? Are there fundamental limitations? Or in other ways, how can blockchain be used to constrain the risks of alignment in AI? Maybe Georgios, can you?
Yeah, I mean, it's a great question. But I would go like one level back, Yeah, so I actually working somewhat on the intersection of these areas. Oh, actually, let me rephrase this. Working on both areas, let's say, of like blockchains and, I would say game theory / AI, like, and being on the committees of a lot of like conferences in this area, I think the intersection is like not quite there, right? So for whatever reason, like there are people who do blockchain and a lot of like interesting work, people who do AI. In some sense, like the computational constraints of these two worlds are like vastly different, right? And then somehow at some point, it seems people like choose one of the paths versus the other, right? And so first of all, I think we need to make these two worlds closer together, right? So yeah, for example, I did mine. Nobody said like, hey, hi, Georgios, like explain to me this about like blockchain. Like there's no such urgency, right? So, but people on the other hand, like they care too much about they care about AI safety quite a bit, but somehow to the extent that blockchain solutions would be an enabler, I think that's not in the conversation right now. Okay, I would want to believe that that blockchains and specific commitments, for all the reasons that we understand from programmable equilibria and generally this literature of cooperative systems should be useful. Okay, but how to actionalize this? I think we're probably going to need a combination of things that in some sense, we need like a trisecta. I think this idea of like, how do you put these two things together? Let's say blockchains, cooperative AI, and for example, this idea of differentiability, that David talked about. If you can describe this, so it's not only that you have to put, let's say, cooperative AI and blockchains together. You also have to put neural networks. Okay, done. I think it's important, right? But you see how just doing two of them together, you're already like in the echelon, like breaking like new ground, right? So now it's about putting everything together. Yeah, good. Let's do it. So I think it's exciting. It's exciting. It's definitely hard work, and the way to do it is to understand the works that are already done on two of the three areas, and try to understand how to add the extra component, actually. Okay. So yeah, and as I said, like this kind of conversation, is definitely, I think, a step in the right direction. Okay. And we should start small. Like that's the other thing. So I think a lot of time when people talk about this about solving everything, and I'm saying no, just give me the epsilon step. That I can believe in. That does not scare me too much. So I believe that we could make some progress there. So I think this is the interesting thing to go for. What are the gradient steps in that direction, right? So that's it. And I don't have good ideas. So but I would say I would invite all of you to try to participate in this discussion.
That's it. So we have some good news. We have a room for, I think, 10 more minutes. Perhaps I would suggest we can move away from the problem of meta coordination and dig deeper into the technical specifics of coordination and specifically program equilibrium. So Vince, you said earlier that there is a work by Kaspar on basically having a population of programs interact with one another and sort of selecting away what is the winner or the dominant or evolutionary dominant program out of them. It feels to me, as I've read more of this literature, that the problem of composition of these programs or how different programs relate to one another is very central to the current state of the art. So could you tell us more about what are the biggest unsolved questions in the field?
Yeah, very good. And so I don't think any of these competitions or other things have had a clear resolution as that this is the right way to do it. But I'd say there's sort of three different approaches. One is to look for identity in programs, right? Like you're looking really for a very specific program that you're actually going to scan, whether it's that specific program, maybe the same one as this program, the program that I am, let's say. That's one way to establish cooperation. And so that's, in some sense, works very easily and is easy to analyze and gives you folk theorems about being able to cooperate and do other things. But it's also very brittle because this really requires coordination on one particular kind of language, one particular kind of thing that you express. And that might at some point fall short as the environment changes and you need something else. Or as you start to interact with another community that converges to a different equilibrium. So that's where that one falls short. There's this other one where people try to do logical analysis of the other programs and actually try to prove things about the program, right? So given a program expressed in some language, we try to prove whether it will in fact cooperate with us. So that's a very interesting direction and gets into lots of unusual mathematical logic results like Loeb's theorem. And so it's interesting, but also a little bit mind-blowing and hard to think about and hard to really get your handle on. And I think that's exactly what happened in this competition that I mentioned before. And I think in some sense, the most robust one that I know about now is actually Kaspar's approach that relies more on simulating the other programs, right? As opposed to trying to really analyze them, just getting to run them. Now, this is tricky because in some cases, this leads to, in some cases, even an exponential blow up in the number of runs that you need to do, that if I need to simulate both of your programs, but both of your programs actually also, try to simulate the other two programs, well, this is never going to end, right? There are some tricks around that we maybe randomly sample some programs to simulate, and we end some things early. So that's, I think, a little bit the leading edge of where these ideas are going. But simulation, in some sense, is a very powerful way to proceed because, if nothing else, like the thing eventually needs to be able to be run, right? So if that's the only property that you can rely on, that whatever crazy thing somebody puts together, at least it has to be reasonable, or otherwise maybe it's just going to time out. Then it's nice to be able to build on that and get the cooperation that way. So that's what I currently kind of see as the most promising approach, especially as these systems would get more complex at some point, right? Like at some point, maybe, like there are all Georgios' points that he just made about, well, the computational, what we can afford computationally is very different when we're talking about a foundation model versus something on the blockchain. But who knows, maybe one day that comes together with off-chain computation or something like that. And in those cases, it really becomes hard to just analyze like, how are you going to analyze the code of a self-driving car? That seems going a bit too far. But at some level, you can audit it, you can run it, and just say like, well, I'm going to put it through the sequence of tests, right? The more I think we can rely on that all we need to do is run the program, maybe run it under different conditions. That I think is probably the most robust way to proceed. And that's a lot of what we've been working on recently, that we just think about simulation access, right? And nothing else, but just being able to simulate it. And even that can give you cooperation in various contexts. So that's where we've been focusing.
Yeah, so this would have been actually my next question. Like, how do you think about developing and, let's say, deploying these programs in environments that are not only complex, but maybe, let's say I need to make a commitment, but the environment in which I am playing, it changes over time. It has a lot of features that maybe I'm unaware of. So are there results of game theory, for instance, that look at how should I make commitment, or how should I deploy my program that plays on my GitHub when I have imperfect information about the game that is being played? I don't even know the full space of strategies or what other players might be doing. Is there something to be said about this setting?
Yeah, very good. So I think in general, you can think about dynamic settings, right? There's a whole literature on dynamic mechanism design, but most of those approaches do require that you have some kind of concept about the kinds of things that could be happening. Once you start going to really open worlds, I would worry about committing to certain things too much, right? And sort of practically in human societies, right? Usually we have ways of rolling back our commitments. Right, that our laws, for example, usually can always be overturned. Some things need, maybe we require a larger supermajority to overrule, but things are fundamentally set up to be somewhat flexible. And so now that also creates some tension, right? Because if you can overturn everything, then commitments stop being credible potentially as well. So that's, I think, where you need to find some kind of balance, where sometimes maybe you need to say, like, well, we're going to commit that as long as things stay within, sort of the parameters stay within certain intervals, then we are in fact committed to do this. But we have some escape clauses that if something really unusual happens, then we can exit from the commitment, right? And I think that's what we see in human life as well, that if circumstances get really unusual, then we change the laws and we change the expectations and we change the norms. You can think about, right, like, for example, in Ukraine recently, like, when that started happening, a lot of the laws were, kind of put on hold and say, okay, well, we're not going to worry about people doing this kind of thing because it's now obviously not our normal situation anymore. I think that's sort of a characteristic of how we as human beings handle this. And there's probably something to that in any sufficiently kind of open world where things might really change drastically, that you need some kind of mechanism by which to come back and say, like, well, okay, all these things that we committed to before made sense in the context when we committed to them, but now that context has changed so much that we need to have some kind of escape clause for that.
Mm-hmm. There's something you, of course. Actually, some thoughts. I mean, the thoughts that I was thinking about is more about maybe a kind of like a concreting application of ideas, right? So I think I think all of these tools are going to be useful, and if they can show that, like, look, there's the blockchain world, like before the introduction of these commitment devices, and the world, like, let's say, after, and now there's this explicit new capability that people actually care about and use, right? Like, think of the example, like, like, let's say, Citi talk about like DeFi markets and like moving like trillions of dollars. Well, clearly people care about that, and then we can talk about like the capabilities that allow this to happen. Now, I think they could interestingly be some new such market, right, that can only be built in the presence of more powerful devices. And I think that's fancy to also like keep in mind, right? Because then, we'll have a reason to actually like jump into these complexities and struggle with them, right?
So for the last 2 minutes that we have, maybe I want to open the floor to the audience if there's any question on the topics. Yes.
What question do you think we should have asked you, but we didn't ask you?
What the meta question?
Oh, yeah.
Yeah. So the question was, what question you should have been asked by the audience, but we did not ask you?
Always a good question, but I think we've touched on what I thought were going to be the most relevant things, right? Again, like, I really like Georgios' idea about thinking about what are kind of the fundamental abstractions or primitives that we want to build off of. what is what, you know, on the cooperative AI side, what is what we need, and then what can be delivered on the actual implementation side. I think that's a really nice place for us all to come together and think what those are. And so, yeah, I would encourage more of that.
Yeah. My ask to this would be not the what, but who. Like, I think you should definitely ask, like, Barnaby, like more stuff, like in some sense, understanding I think the more you understand like the present capabilities of the of the blockchain ecosystem as a computing formalism, like that would be the most useful thing to take home. Especially if you don't have a background in this. Okay, so like, sometimes your goal after today is to say like, okay, here's like my, Turing machine abstraction of a computer, right? But for the Ethereum. And then somehow like, if you can, and then like, if you can get, if you're going to go home with a much better such approximation, I think that's very, very useful. And asking Barnaby is the best way to do that. And the other practitioners, I would say, either Barnaby is my proxy for like, all of the people who do the hard work, Okay, that's it.
Yeah, thank you both. It was a very engaging session. Yeah, hope to see you soon.
Awesome. See you. Bye.